Alright, y'all, I'm going to try to split this into 3 videos for hyperbolas. So here we go. Okay, so first I'll talk about the kind of what a hyperbola is, then we'll do 2 different videos for examples. Okay, so here we go. So first of all, a hyperbola is something essentially that looks like this. Okay, that's the general shape. We can kind of zoom in and get an idea there of what a hyperbola is. Now keep in mind it's 2 different ways. Okay, you can either have kind of like this shape, right, like these, or you could have it like this. Okay, so essentially it can be kind of, I like to think about this as the horizontal one, and then you've also got the vertical one. Okay, so let's talk about what the definition is of a hyperbola. So continuing with conics, this is the definition. Okay, now it's wordy, but we're going to get into what it means in just a sec. Okay, so the hyperbola is a locus of points in a plane where the difference of the distances from 2 fixed points called foci is always constant. So if you remember with the ellipses, it was essentially the main difference is an ellipse with the foci, the sum was the same, remained the same. Now it's the differences. Okay, so that's the main change between ellipses and hyperbolas. All right, so that's the definition, but let's actually talk about what that means. Okay. So essentially what you have is, I kind of did it with this little thing right here. Scoot this over. All right, is you have the foci, which are these 2 right here. Okay, now the difference between the distances. So what I did with A is I made it to where it measured the distance. Okay, and then it also measures the difference between those. So notice I put absolute value, so it's the big one minus the small one. Just essentially you can just trust me here that those are the actual distances between. Now what we can see is actually in the beginning, okay, this was here, okay, and it was right there. Now essentially what we have, okay, we'll go with the 5.9 now. Now what the difference is what is the distance between A and F1? Well, that distance is 2, okay. So 2 lengths here, and then what's the distance between this? Well, let's go ahead and count. So this is 5, right? 3, so 8. So what is 8 minus 2? Well, that is going to be that about 6. Okay, now what we're going to see is that this is going to be the case for every single point along here. Now, it's not going to be perfect, but you can see over here that everything is hovering around 6. Okay, so it's getting very close in there. It's not perfect because I can move this thing everywhere, but it should always be 6 if it was going to be on that exact hyperbola. Okay, so you can see that in here. That difference remains about 6. Now it's the same thing over here. Notice when I move A up here, this length kind of becomes bigger, and then it's the opposite the other way around. But regardless, here we go. Same thing. You still see that that main difference of 6. Okay, so that's kind of the definition of a hyperbola, just to give you some background. Okay, so the first thing we want to start with is the equation, essentially. Now, HK, or kind of the parts of the equation. I'll show you in just a sec, but here's the center, okay? That's going to be, basically you have your, what we call vertices, okay? It's going to be smack dab in the middle between your vertices. So the center's here on the horizontal one, and then the center could be here for the vertical one. Okay, so that takes care of that. The next part we need to talk about is the transverse axis. Okay, now the transverse axis is going to be that main axis there that actually connects those 2 vertices. So in this particular one, this is your transverse axis. Okay, that's this section right in here. Okay, and I'll write those words, or I'll show you on the textbook when we get the chance, but that is the transverse axis. Okay, and this is the other one called the conjugate axis. So it's, your transverse is here, okay, conjugate's here for this one, but it flips when these 2 flip, right? So you got your transverse axis here, okay, and then your conjugate axis this way for that particular one, okay? And again, we'll talk about the transverse axis and what importance that is later. Okay, so let's talk about this picture right here. Okay, so this is the standard form of equation of a hyperbola. Okay, it's these 2. Now notice the transverse axis is mentioned here, right? Transverse axis is vertical, transverse axis is horizontal. Now the difference between these is when x is first, okay, right? So you got x, blah, blah, and then minus y, blah, 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 right? Notice they're flipped, okay? So y here, x here, x here, okay? So whatever's first determines if it's vertical or horizontal, okay? So again, whatever is first determines if it's vertical or horizontal. If x is first, okay, the transverse axis is going to be horizontal. If y is first, again, we're subtracting, then the transverse axis will be vertical. Okay, that's super important moving forward. Okay. Now, I do want to point out that unfortunately the textbook is incorrect about this equation. Okay, so please go by this equation, not the one in the textbook. The textbook lays out everything else great, but this is incorrect. Okay. All right, so let's go ahead and look back here and kind of talk about what is important with that transverse axis. Okay, so let's look at this equation here. So we have y first. Okay, so y first up here, right? So it's telling me that the transverse axis will be, vertical. Okay, so the transverse axis is going to be vertical on that example that I was just looking at. Okay, and that's what we see here, right? It connects the vertices. Okay, so the trans-axis is indeed vertical. Okay, now the reason that's important, all right, is because if you remember, right, it's very similar to ellipses in some regards. Okay, but what you need to remember is that A is always going to be on the transverse axis. Again, A is always going to be on the transverse axis. So for this particular one, okay, this length is A here. Okay, this is my length of A. So in this particular one, it is 3, right? So 1, 2, 3, and then 1, 2, 3. Okay, so that's my A, and that is going to be right here. Okay, so that is, that's why my value here is 9, right? Because it's 3 squared, and so that value is 9. Okay. And I'm going to take you to the textbook, but real quick, I do want to just show you, okay, that you also have asymptotes on hyperbolas. Okay, so that's the asymptotes going on here. We're going to find out how to actually get those values later, but for now, just understand that there are asymptotes to kind of lead you into drawing it. Okay, and then also over here, just to show you, those are also asymptotes. Okay.